All right, so I'm going to go ahead and do question number 7 from the review. I'll also post it in the description of the video just so you have it there. So the question reads, water is being pumped into a conical tank that is 8 feet tall and has a diameter of 10 feet. If the water is being pumped in at a constant rate of 3/5 cubic feet per hour, at what rate is the depth of the water in the tank changing when the tank is half full? So we'll go ahead and sketch out a little picture here. There's our cone. Since our diameter is 10 feet, our radius is going to be 5 feet. And our height is going to be 8 feet. All right, so we're going to have to set up a couple equations here. First, we're going to have the volume of a cone, which is 1/3 pi radius squared h. Okay. I'm going to go ahead and write my equation here in terms of h because I'm looking for, of course, right, the change in height or depth of the water. So I'm looking for dh dt, and I'm given dv dt. Okay. I don't really need to worry about dr dt. So I'm going to say that I've got, if radius equals 5, height equals 8, then I can say, well, the ratio of radius to height is 5 to 8. Multiply both sides by 8, and I get my radius is equal to 5/8 my height. Okay. So I'm going to go ahead, fill that in. Instead of radius squared, it's going to be 5/8 height squared times h. We'll go ahead and simplify this a bit. 1/3 pi, I'm going to just write that as pi over 3. Square everything in there. 25 over 64 h squared times h. And I'm going to just get my h terms together there. Okay, now I'm going to go ahead and derive with respect to time. So we're going to get dv dt equals, okay, we're going to take that 3, pull it up front, 3 times pi over 3 times 25, 64 h squared, and that is with respect to time. Go ahead and cancel our 3's, and I'm left with dv dt equals pi times 25 over 64 h squared dh dt. And this is where we have to be careful and where I made a mistake a few times in trying to solve this. In our question, okay, it notes that the tank is half full. Because this is a cone, right, the halfway point on our height is not going to be where the water level is if the tank itself is half full, right? Fullness is referring to volume, not height. So what I need to do is I need to now solve for what my height would be if my cone were to be half full. So I'm going to just use my original equation here. And we're going to solve for volume if it's full, and then we're just going to cut it in half and use that. Okay. Okay, so radius squared and height is 8. Okay. We've got 1/3 times pi times 25 times 8, or we multiply across 200 pi over 3. Okay? And just to make it easier, I'm going to actually do this with my rewritten equation in terms of height. It'll just make it a little easier to cancel things later on. Our height is 8. Okay, and we get cubed is 512. Okay. Now, what I'm looking for is, of course, half of that. So I'm going to call this V sub 1/2, just 1/2 of the volume. And we're just going to multiply this by 1/2. Okay. From here, now we need to actually go ahead and do a little solving. So we're going to take this value that we just got. Okay. And we're going to set it equal to our volume with height unknown, because we're trying to solve for our height, right, with this specific volume. And this is where writing it this way will come in handy as opposed to this. Pi over 3. Okay, so write anything same on both sides. So I'm just going to cancel out. It's pi over 3. That's gone. 25/64. That's gone. So I'm left with 1/2 times 512 equals h cubed. So I guess what is that? 256 equals h cubed. And we're going to go ahead and take the cube root of both sides. So I get the cube root of 256 equals h. Now, we can go ahead and take this put it in for h. I can go ahead and take my 3/5, my dv dt, change in volume with respect to time, plug that in, and it'll leave me with just the unknown of dh dt to solve for. Okay, so 3/5 equals pi times 25 over 64 times cube root of 256 squared dh dt. Okay, and then our last step, right, is we need to divide 3/5 by this right here. And the question or the solution to this on the paper that was given was approximated. That's why we're doing it like this. We're going to just end up with a decimal or an approximate decimal. And we get dH dt is approximately, let me double check my answer here. Hang on just one sec. It is going to be approximately 0.012, so about 12 thousandths, and our units is going to be feet per hour because it's our change in height with respect to time. So there we go.